State Stokes law. State Stokes law. Stokes law. When a spherical body, so Stokes law is only valid for the body whose shape is spherical, like air drop, air bubble, steel ball, copper ball. So it is valid only for spherical body. When a spherical body falls or rises in the liquid, or I can say fluid, air is a fluid. So when a spherical body falls or rises in the fluid, it can be liquid, it can be gas, then the viscous force acting on the body is directly proportional to coefficient of viscosity, radius of the body, and velocity by which it is moving. So viscous force is proportional to eta r v. Therefore, F is 6 pi eta r v, where 6 pi is constant, called as Stokes constant. This is our Stokes law. Only valid for spherical body. So when a spherical body either falls or rises in a fluid, fluid means it can be liquid, it can be gas, then viscous force acting on the spherical body is, first point, directly is directly proportional to, first point, coefficient of viscosity eta, second, radius of the body r, third, velocity with which body is moving v. Therefore, F proportional eta rv, F equals to 6 pi eta rv, where 6 pi is constant, called as Stokes constant. This is known as Stokes law. I think everybody followed Stokes law?
Yes, sir.
Okay, right. When a spherical body, in this week I will complete this chapter. Next week I will start with that oscillation wala chapter. When a spherical body falls or rises in a fluid, then viscous force acting on the body is directly proportional to the, viscous force is directly proportional to the, first, coefficient of viscosity in bracket eta, second, radius of body capital R, third, velocity of body v, velocity of body v. Therefore, F proportional eta R v. F equals to 6 pi eta R v. Where 6 pi is a constant. Where 6 pi is a constant called as Stokes constant. This is known as Stokes law. Yes, completed. This is known as Stokes law.
Yes,
Yes,
sir.
sir.
Okay, okay. Next study. Deduce Stokes law by method of dimension. That means obtain Stokes law by method of dimension. According to Stokes law, reduce Stokes law means that 6 pi eta RV we have to obtain. According to Stokes law, the viscous force F acting on moving spherical body depends upon. So whenever you want bi-dimension, you should know dependence of that quantity. So I want F, it depends upon coefficient of viscosity denoted by eta. Coefficient of viscosity denoted by eta, radius of body denoted by r, then velocity of body denoted by v. Please copy this much. Yes, done till this?
Yes, sir.
Yes, sir.
Okay, dears. Therefore, I can say F is proportional to eta R V some power A B C. You can write X Y Z also. So F is K eta R V power A B C. Now, dimension where K is proportionality constant. Where K is proportionality constant. Now all the quantities on left and all the quantities on right should have same dimensions. So dimension of F must be dimension of K eta R V power A B C. Now F is M1 L1 T minus 2. But K is dimensionless. What is eta dimension? Are you able to remember? M1 L minus 1 T minus 1. Correct? No? Eta dimension. Eta means coefficient of viscosity.
Yes, sir.
So we got M1 L minus 1 T minus 1. Correct? Correct now?
Yes, sir.
Okay, very
Yes,
good.
sir.
L raised to B. V is L1. T minus 1 raised to C. So M1 L1 T minus 2 equals to M raised to A. L raised to minus A plus B plus C. T raised to minus A minus C. Now equating powers of same basis, we get A equal to 1. Minus A plus B plus C is also 1. Minus A minus C is minus 2. So we got these equations. Now if I put A in fourth equation, I will get C, and put A and C in third equation, I will get B. Please copy till this. Complete till end. I have written everything on the board, on the screen in fact.
Yes, sir.
Yeah, please copy till end. Once you all complete full, please tell.
Done, sir.
Okay, others have also done.
Yes.
Last line is this reduces Stokes law. Till that. Okay, can I clear it everything now?
Yes, sir.
Okay,
Yes, sir.
okay, okay. Define terminal velocity and derive its expression. DAV का fixed question है ये for 4 marks. Define terminal velocity and derive its expression. Terminal means what? Start or end?
End, sir.
स्टार्टिंग भी हो सकता है कभी कभी ना, जैसे CST छत्रपति शिवाजी टर्मिनस, ये स्टार्ट भी है कोई ट्रेन के लिए, एंड भी है ना.
Yes, sir.
So that means where everything comes to halt is called terminus, or it starts from there is called terminus. So if I have a spherical body, I place in air or on a liquid whose density is less, तो ये अंदर सिंक होएगा ना ऐसा. If this is one body whose density is greater than density of liquid, तो ये सिंक होएगा ना अंदर ऐसा ड्यू टू ग्रेविटी.
Yes, sir.
सो जब ये सिंक होएगा तो अपना वॉल्यूम के जितना लिक्विड का वॉल्यूम को डिस्प्लेस करेगा ना. हेलो,
Yes, sir.
व्हेन अ बॉडी इज इमर्स्ड, दैट मींस जितना उसका साइज है उतना वो लिक्विड को डिस्प्लेस करके अपना जगह बनाएगा ना. दैट मींस इट विल ऑक्यूपाई द स्पेस आफ्टर डिस्प्लेसिंग द लिक्विड इक्विवेलेंट टू इट्स ओन वॉल्यूम.
Yes, sir.
Okay, now just listen. When a spherical body having higher density is placed on the surface of liquid, then it falls due to gravity. Hence its velocity goes on increasing, because gravitational pull will increase the velocity. Velocity goes on increasing. Thus viscous force goes on increasing, because viscous force is 6 pi eta rv. When velocity increases, viscous force will go on increasing. Viscous force means opposing force. But along with this, by Archimedes' principle, when body is partially or wholly immersed in liquid, it experiences loss of weight due to buoyant force or buoyancy. This is called law of flotation. In lower standard, you might have heard. So this is the body. It is pulled by gravity. That means its weight, and opposed by viscous force plus buoyancy. Buoyancy is constant, weight is constant, but viscous force goes on increasing. So suppose gravity is 10, buoyancy is 2, ये 0 से चालू होएगा, कभी तो 8 हो गया, तो 8 प्लस 2 मिलके 10 को बैलेंस किया क्या नहीं?
किया, sir.
अगर बैलेंस कर दिया तो नेट फोर्स कितना? 0.
0.
नेट फोर्स 0 तो m में कितना? 0.
Yes.
m में अगर 0 तो चेंज इन वेलोसिटी 0. Change in velocity 0 मतलब velocity is constant.
Yes.
This constant velocity is called terminal velocity. कॉन्सेप्ट समझा पहले क्यों टर्मिनल बोलते हैं? क्योंकि अभी ना इंक्रीज होएगा ना डिक्रीज होएगा. The end.
Yes, sir.
So when a spherical body is having higher density is placed on the surface of liquid, then it falls due to gravity. Therefore velocity goes on increasing, viscous force goes on increasing. A stage is reached when viscous force plus upthrust or buoyancy balances weight of the body. Thus net force acting on the body becomes 0. Body moves with constant velocity. This constant velocity is called terminal velocity. Everybody followed the definition?
Yes, sir.
Yes, sir.
Then please start writing. When a spherical body of higher density when a spherical body of higher density is placed on the surface of liquid. When a spherical body of higher density is placed on the surface of liquid, then it falls due to gravity. Hence, its velocity goes on decreasing. Velocity goes on decreasing. Thus, velocity goes on increasing, or even decreasing लीजिए. Velocity goes on increasing, not decreasing, increasing. Goes on increasing. Hence, viscous force goes on increasing. Hence, viscous force goes on increasing. A stage is reached when viscous force and buoyancy balances weight of the body. Balances the weight of the body. Hence, force acting on the body becomes constant, and thus force acting on the body becomes zero, and thus velocity becomes constant. This constant velocity is called as terminal velocity. This constant velocity is called as terminal velocity. Done?
Yes, sir.
So definition over. Now we are interested in derivation. Formula of derivation. Consider a body of density rho to be placed on surface of liquid having density rho 0. The body falls due to gravity. Let B be the terminal velocity. Therefore, at terminal velocity, comma, viscous force plus buoyancy equals to weight of body. Please copy till this, then I'm putting the values for each term. Yes, can I clear this?
Yes, sir.
Yes, sir.
Yes, sir.
Now viscous force means 6 pi r eta v, and buoyancy means weight of volume of liquid displaced. buoyancy का मीनिंग लिख देता हूं पहला, weight of volume of liquid displaced, and this should balance weight of body. Now 6 pi r eta v, weight means density. See, we want weight of volume of liquid displaced. So weight means mg, m is density of liquid. I'm writing rho 0 into volume of liquid displaced is volume of solid into g, and weight of the body is density of the body rho into volume of body into g. Now 6 pi r eta v plus rho 0 4 by 3 pi r cube g equals to rho 4 by 3 pi r cube into g. 6 pi r eta v is rho 4 by 3 pi r cube g minus rho 0 4 by 3 pi r cube g. Please copy till this. For DAV student, this is fixed derivation for 4 marks to be asked in the exam.
Done, sir.
Okay. Shall I clear that?
Yes, sir.
Yes.
Anmol, Mank, Dhruv, what you all are practicing now? Which chapter you are practicing? Any new MCQs?
Sir,
So
I'm
elasticity. I was practicing elasticity.
Okay, ठीक है. 6 pi eta rv. अब इसमें से कॉमन लेता हूं. 4/3 pi r cube g constant rho minus rho 0. Can I take in the bracket?
yes, sir.
Yes, sir.
So velocity will become 4/3 pi r cube g upon 6 pi eta rv. This is rho minus rho 0. So pi pi cancel, 1 r का r square cancel. तो क्या बचेगा अभी? 2 into 2 4, 2 3 is 6. So if I look carefully, numerator 2 r square g upon 3 into 3 9 eta. ये क्या कर दिया? सॉरी ये नहीं है. 6 pi eta r है ये r. V is kept here only. Rho minus rho 0. So V becomes 2r square g upon 9 eta rho minus rho 0. This is expression for terminal velocity. Now copy till end. This is expression for terminal velocity.
Done, sir.
Okay. Everybody is done?
Yes, sir.
Yes, sir.
This Sunday you will have test on elasticity and gravitation MCQ. Is it okay?
Okay, sir.
Okay, sir.
Elasticity, gravitation. Next. Reynolds number. Reynolds number. Reynolds performed number of experiment using different liquid flowing through pipe of different diameters. So Reynolds performed number of experiment for the streamlined flow of fluid or for a non-viscous incompressible fluid. Non-viscous मतलब इसका opposing force is negligible. Incompressible means density will remain constant throughout. Incompressible liquid. and proved that critical velocity of liquid is directly proportional to coefficient of viscosity and inversely proportional to density and diameter. By experimentally proved this relation. So critical velocity is proportionality constant nr eta upon rho d, where nr is called as Reynolds number. Thus Reynolds number is Vc rho d upon eta. So whatever you get by solving this, that number is called Reynolds number. Again I am repeating. Reynolds performed number of experiment with non-viscous incompressible fluid, or you can say liquid, one and the same, and proved that critical velocity Vc is directly proportional to coefficient of viscosity and inversely proportional to density of the liquid and diameter of the pipe. So Vc equals to nr eta upon rho d, where n suffix r is a constant called as Reynolds number. What will be unit of Reynolds number? Number है ना, तो it is unitless and dimensionless quantity. So one year they had asked what is dimension of Reynolds number, and option was given M0, L0, T0. बराबर है ना? No
Yes,
dimension of
sir.
the
Yes,
M0.
sir.
Right, till this. Write down. Reynolds performed number of experiment. Reynolds performed number of experiment and proved that Reynolds performed number of experiment for Reynolds performed number of experiment for Reynolds performed number of experiment and proved that Reynolds performed number of experiment for non-viscous incompressible fluid. Non-viscous incompressible fluid, and proved that critical velocity for given liquid comma Vc, then copy for critical velocity for given liquid comma Vc proportional, ये पूरा एंड तक लिखो.
Done, sir.
Okay. Then right. Importance उसका आगे ही है of Reynolds number. Importance of Reynolds number. First, if Reynolds number n suffix r is less than 1000, then flow of fluid is streamline. Second, if Reynolds number nr is greater than Reynolds number is less than 100,000, then streamline flow. If Reynolds number is greater than 2000, then flow is turbulent. Third, if Reynolds number lies between if Reynolds number lies between 1000 and 2000, lies between 1000 and 2000, then the flow can be either streamline or turbulent. Then it can be either streamline or turbulent. Either streamline or turbulent. Yeah, everybody is done till this?
Yes, sir.
अभी ना ये अपना चैप्टर मैकेनिकल प्रॉपर्टी ऑफ लिक्विड 3 पार्ट में डिवाइडेड है. फर्स्ट पार्ट एक्चुअली प्रेशर था, सेकेंड पार्ट ये सब है, थर्ड पार्ट सरफेस टेंशन एंड बर्नौलीज प्रिंसिपल. सो आई फर्स्ट अटेम्प्टेड सेकेंड पार्ट बिकॉज इट टोटली न्यू था. एंड मोस्ट ऑफ द इनफैक्ट सीबीएसई में फर्स्ट पार्ट मोस्टली डिलीटेड होगा, बट फॉर एंट्रेंस आई एम डूइंग एवरीथिंग. So as per the requirement of the exam of 11th, I have completed your topic. But I will take 3 lectures more to complete 4th chapter. As I said, after that, I will start with oscillation. Very important chapter for entrance. And then wave. And then only left out is thermal properties and KTG radiation. So after oscillation, I may start with KTG radiation depending upon America exam में ये chapter है क्या नहीं. Then last 2 chapters, waves and thermal. This is December going on. January, February. Feb end will complete entire syllabus. Then I have told full March, it will be revision. And April 1, I will not make April Fool of yours, but will start after 1, 12 standard chapters. This is how we are going to proceed. Yes, Vaibhav?
Yes, sir.
What is pressure, beta? चलो इससे पहले आप लोग बताओ what is thrust? When we say thrust, what does it mean? Is it force? Is it area? Is it volume? It is velocity? What it is?
Sir, force.
It is force. तो कोई भी फोर्स को थ्रस्ट बोलते हैं क्या हम लोग? जैसे
No,
ये
sir.
बॉडी है, इसके ऊपर ऐसा फोर्स एक्ट हो गया, ये थ्रस्ट नहीं है. लेकिन अगर नॉर्मली एक्ट हो गया तो इसको हम नाम देते हैं थ्रस्ट. सो थ्रस्ट इज एक्चुअली व्हाट? नॉर्मल फोर्स एक्टिंग ऑन द बॉडी. राइट, फर्स्ट डिफाइन thrust. the normal force, acting on the body, or you can say on the surface of body, is called as thrust. The normal force acting on the surface of body is called as thrust. Its SI unit is Newton and CGS unit is dyne. And CGS unit is dyne. 1 Newton is how many dyne? Is it 10 raised to 5?
10 raised to 5.
Yes,
Yes,
sir.
sir.
करेक्ट. इतना लिख लो थ्रस्ट का डेफिनेशन, फिर प्रेशर स्टार्ट करता हूं. After pressure, we have to deal with pressure on the liquid due to liquid. Then Pascal's law, application of Pascal's law, that will complete our first part. Second part already I have done. Third part is related to Bernoulli's principle and surface tension. State board वाले को 12th में ये सब जो अभी मैं करा रहा हूँ. So this chapter which we are doing, mechanical property of fluid, for state board student this is in 12th standard. ये 12th standard का second chapter है. Once you are done, please let me know.
Done, sir.
Okay. What will be SI dimension of thrust? Dimension of thrust. Anmol,
Yes, sir.
what will be dimension of thrust? Dhruv, what will
Sir,
be dimension?
M1 L1 T raised to minus 1.
No. Dhruv,
M1 L1 T trust, right?
M1 L1.
T minus 2.
Correct.
T minus 2, T minus 2.
Correct.
हाँ
क्योंकि thrust तो force ही है ना,
force yeah.
तो force का dimension आएगा. इतना क्यों wrong होने का टेंशन ही नहीं लेना. इसने तो लिखा दिया it is nothing but force. तो force मतलब thrust. तो जो force का dimension वही thrust का dimension. Next, right?
Yes, sir.
Pressure. Yeah. Next one, pressure. Thrust acting per unit area. Thrust acting per unit area. Thrust acting per unit area is called as pressure. Therefore, pressure equals to thrust upon area equal to normal force upon area. It is a scalar quantity. ये याद रखना अच्छे से. एरिया वेक्टर है, फोर्स वेक्टर है, but a ratio scalar. It is a scalar quantity. Its SI unit is Newton per meter square, or it is also called Pascal, denoted as PA, or Pascal. Its CGS unit is dyne per centimeter square. You are written. Hello, completed?
Yes, sir.
Can you tell me its dimension?
M1 L minus 1 T minus 2.
Yeah, correct. Its dimension is M1 L, how much? Minus 1 T minus 2. Written, huh?
Yes.
So today we stop here. Next lecture